Welcome everyone. This is our working group device management meeting from September 16th, 2025. Remember, this meeting falls under the CNCF Code of Conduct, which basically means be excellent to each other. I checked the agenda. We don't have anything in particular to discuss, so we can do the usual thing. New participants, if we have any, can introduce themselves, express their interest in what they want to discuss or do, or raise any open questions. And if we don't have anything else, I can give a short status update and then open the floor for questions. So anyone who wants to raise something? Yeah. Okay.
Not really.
Oh yeah. So status, I don't remember what this is the first meeting after the GA after the 134 release. So let me just check my notes. August 27th, that was before the release, I think. Anyway, I'll just recap. So yes, DRA is GA in 134. There was some excitement after I came back from vacation around conformance testing, but we've settled that. So the requirement to have conformance test coverage for GA is kind of a requirement according to the CAP document, but in practice it has always been something that just got added later on, and we are going to do the same again for DRA. So I have one PR open to add conformance tests, and that PR will go into 135, which is one release later. And actually the CAP template has been updated to document that it's okay to add conformance tests later. In terms of quality, yeah, we had one regression in 134. Unfortunately, the connection monitoring in Kubelet turned out to be to not handle the idle timeout, gRPC idle timeout. So after 30 seconds, Kubelet encountered the idle timeout and then ran into a mutex deadlock, which made the connection to the DRA driver unusable. So if you have a long-running 134 cluster with not much activity between kubelet and DRA drivers, you may see that bug. Restarting kubelet helps, and enabling as a stopgap measure, enabling the DRA resource status of device health reporting in the pod status. That alpha feature keeps the connection busy and prevents this idle timeout from triggering. That's strictly a workaround. The actual fix has been identified and will be merged. It came in too late for 134.1. That was already starting or preparing for that patch release already started the deadline was end of last week. Preparing the patch release happened in parallel to developing this fix, so it's too late for that. But there will be a 134.2 with that fix included. And it just shows again that real world testing of release candidates is important, and it didn't happen in this case. I think we all tested release candidates, or we had all our upstream tests, but having a cluster set up and not doing anything for half an hour, it's not just something that you normally do in the CI job, for example. So yeah, now that we know that this idle timeout does occur and it does go through the code that we wrote for connection monitoring, we of course have a unit test and it passes and it's fine. It runs in the CI, but if you don't know that, it's just really hard to find something like this. Anyway, the other features that we merged into 134 seem to be okay. Well, consumable capacity had a similar issue. It's also not really usable in 134. So one edge case hadn't been considered, and the code just doesn't handle scheduling correctly in all cases. But it's an alpha feature, so we're not going to backport. People who want consumable capacity basically have to continue working with master, and well, we'll fix it. That's a minor thing. It's just really annoying that we had this alpha feature and we now can't use the release to preview it, but that's not the end of the world. It just happens.
Okay, I may ask about like the 135. What are the most hot topics right now?
Yeah.
So I
Um,
frankly I was focusing full of my attention to gang scheduling discussions that we had, and something we are trying to achieve in scheduler for the next release. So I might be overlooking for something.
yeah, I'm checking whether I have the. Yeah, I do have it. Just a second. I can share the table that John is maintaining. Let me. Yeah, I can share it. Just a second. Almost there.
Yeah, I'm aware of the table.
Yeah. Okay. So in terms of priorities for DRA, I think it's the extended resources API support.
Mm-hmm.
Where do we have it?
The first
The
one,
number one.
yeah.
So extended resource requests via DRA. That was alpha in 134. Quality, yeah, well, we identified a few problems. People are actively working on it. There's an ongoing weekly meeting by people interested in that feature, or who are working on this feature to move it forward. So they are making progress. And that's important because it
Oh,
really simplifies real world deployments. And
okay.
that's,
So you are saying that there is a weekly meeting about this feature, right?
yes. Yeah.
Okay, so
John Bellameric set up something. You, of course, is involved at Bartosz from Intel. Uh, a few others basically taking this through, have identified problems, have assigned owners for these problems, and they are working through that right now.
okay, so I can have a closer look into that.
Yeah. Well, they are using this meeting to just organize the work. So eventually, all of the things will still show up as PRs against upstream, and we will. And I at least expect a full explanation of why they are fixing things also in the PRs of it. It can be reviewed for by someone who is not in that meeting.
Yeah,
Uh,
just to add, I think the issue was created and we identified areas of the development so far and assigned the issues to respective owners. So that's all we had a meeting regarding the extended resource request via DRA.
Okay,
so
I can in yeah, I'm part of this and
good.
I wanted to work on adding this global cache issue related to this. So maybe I can share the link of the issue.
Yeah, I remember seeing a question around it, and it became a bit clearer that it's a global optimization because the pre-filtering or it can help avoid some pod scheduling attempts that don't succeed.
Yeah, I'm also like actually going through the code and issue, etc. So I just started working on it.
Yeah. Okay, so we do have a tracking issue with. By the way, I'm still sharing the whole window, right? So you can see the issue, I
Yes,
suppose.
yes.
Yeah, yeah.
mm-hmm.
So yeah, there are a few things, few areas that need work. And so
Okay,
that's a priority. People are working on it. Um, the resource health status, I think that needs some cleanups. I mentioned those on Slack for this is being worked on. But it's minor in terms of priority. It's more like code health. There were some discussions around how to represent device health. There is one tentative cap by John on that, but I think we are now more leaning towards including a bit more device health or information or general information in the device tains. So that would be my cap 5055. I have a cap update pending for that one, where I'm basically allowing the API to represent tains with more information, including free format raw data in a format that is specified by the vendor, similar how a network device driver can publish information in a resource claim status. And a key point is that a device taint can have no effect. It's just really purely informational. I think that covers many of the use cases that we've discussed since then about how to publish health information in a cluster, how to have someone else than the driver make a decision about how to mitigate those observations. So that I think is something that I want to implement myself in the next cycle in 135. It's listed here still as beta, but I think that's not realistic. There are significant API changes, and doing those together with a promotion to beta just isn't right. It skips the part where people get a chance to look at that API in an actual release. So we would need a much closer feedback loop from implementing that new API early on in the 135 cycle, then have people try that out and confirm that it works for them, and then do a promotion perhaps at the end of a cycle. But I'm not sure whether we can pull that off.
Okay.
The partitionable devices, yeah, there's certainly interest in that to promote it. The mix-ins that got delayed already once, and I think we are now considering a different approach how to handle resource slices. So that may go into alpha. Yeah, and then there is interest, and I think that is the one that might interest you most, reserved for workloads. That's the question of how core Kubernetes components like the resource claim controller, the one that is responsible for deallocating a resource claim, how can they track ownership or usage of a resource claim, of an allocated resource claim, by more than individual pods? So that goes straight to a question of how to do gang scheduling. How do we even identify who is using a resource claim if it's not a single pod or a set of pods, or without listing the individual pods? That was the original problem, that by listing individual pods we run into the size limit for that list that we have in the resource claim status. And this whole discussion in that cap is about why do we have that list? What if we reference some higher level object? The problem then becomes that the in-tree components need to know whether that higher level object still has pods running, or whether it's safe to deallocate, knowing that no pods for that higher level construct will appear in the future. So that's one of the technical aspects that makes it tricky. The other is which higher level construct should be supported in the first place. If there are multiple workload controllers, they all have different APIs. Do we need to support all of them, or can we map all of them to one common API type?
Like the current discussion and the proposal is to have the abstract workload object, which could be used by everyone. The question is whether it's enough to list this object as a reserve for, because the number of pods in that object would be probably mutable as well.
So that I've not looked into it recently. That's I just know that these discussions are going on there.
Right. So there is also an option to reference the internal elements of that object, which would represent, in fact, gangs. And the issue here would be that no all components would be required to use gang scheduling of scheduler. So if some component is not using it, then it would be not possible to go into lower granularity than workload. Yeah, it's developing. So yeah, I will also think about that.
Yep. Then, yeah, the folks behind device binding conditions, they are definitely interested in moving it forward and keep asking for reviews. I don't know whether they actually have addressed all criteria for beta. I have not checked that. And there's another complication where John Bellameric had a new use case that would require changing some of the aspects of it, which goes back to, do we do that as part of the 5007 binding conditions cap, which implies API changes, which might imply delaying the beta for another cycle, or do we another cap with just that add-on under a separate feature gate? And that's undecided at this point.
Mm-hmm.
And here's the one above that. That's the one that I mentioned with device health. John's idea was to do it in the resource slice status, but I think we've moved away from that. So this cap actually might not be relevant anymore.
So if we have some time, let me ask about how we represent resource claims and allocations of the resource claims to devices, because we keep both in the resource claim object.
That's correct, yes. Mm-hmm. So the concept is currently that resource slice is read-only information. The actual ownership is with individual schedulers for the node, and they completely own all resource slice devices for that node.
You mean schedulers or device managers?
So in terms of allocation, it's the scheduler.
Okay, in terms of tracking, how much?
Yeah, how much is available, how much they can use, how much has been allocated. And the recording of the allocation then happens in the resource claim status. So that's the source of truth for a device is in use.
Sure. So that means that anyone who wants to use the array resources have to use resource claim object, obviously. There is no way around that.
Yes. And the other thing is, if you have two different entities, let's call them schedulers or workload allocators or whatever. If you have two, well, traditional use case, it would be schedulers. You have two schedulers scheduling to the same node. That's a conflict. There's no coordination between those two.
Other than a single scheduler, which could...
Yes. The serialization of scheduling to one node happens by ensuring that there is only one scheduler which schedules pods. And that is true also for the other resources on a node. It's true for RAM, CPU, and now also for DRA devices and extended resources. These are all resources associated with a node, and the assumption is that the scheduler doesn't need to coordinate with anyone else when making scheduling decisions.
Right.
Yeah.
So that's one of the ideas of how we can do workload hour scheduling, that we could have several workload schedulers, but eventually they have to like talk to kubescheduler to coordinate the resource allocation and like resolve any races that happen between them.
Yeah. So I know that Q, for example, does its topology aware scheduling. So I think that works by basically predicting a certain state, then creating pods and hoping that it plays out as expected, right?
Yes,
Yeah.
and it
So
goes
if nothing else creates pods in the meantime, that's a fairly good approximation, and kubescheduler will do what Q was expecting it to do.
Right, there are a few problems. There are problem of races, of course, and there are problem of accuracy of the queue scheduling, which is also another problem. But the good thing is that Q is using kubescheduler underneath. It's not that obvious for other schedulers which recently appeared. Some of them do binding as well.
Yeah.
So
for DRA, I have a long-standing idea that the resource slice, now not the resource claim, literally the resource slice status could be used to coordinate allocation of devices.
Okay, why?
Because then we could have two schedulers scheduling and actually scheduling pods. Say, for example, if you consider a network attached device, there is no clear owner. You could have two schedulers being responsible for different nodes, both trying to use the same network attached device. That's one area where this whole approach of sharding your cluster among different schedulers doesn't work for network attached devices, because
right,
then
but cannot we address that by resolving conflicts on one scheduling level?
No, if you so suppose you have two nodes, one scheduler per node, and you have one network attached device that could be used on either of these.
Okay.
Both schedulers will assume that they not only own the resources on the node, but also that network attached device. So they will conflict with each other. They might both schedule pods to their own node, and both pods might have a resource claim, a different resource claim referencing this network attached device. And we might end up with two resource claims referencing the same device, which is not valid. And that's because there's no way between these two schedulers to coordinate who gets to use that network attached device.
Right, but the direction we are going into is to have a concept of reservation and proposal of the reservation, which those two schedulers can emit. But the actual turning those proposals into the actual reservation would be only performed by kubescheduler or the default
A single
scheduler.
entity. So you would have to have a single entity that arbitrates, right?
Yes, and so one of the resource claims updates would be, or proposals would be like rejected.
Yeah.
So that's one approach.
Yeah. My thinking was that for DRA, the resource slice status could be the place where such reservations get recorded.
Okay, so you mean that there will be one place in which has to be updated in?
Yes. Yeah. So
What about creating yet another object that represents the allocation reservation that would sit in the middle?
Yeah, that could also work. I suppose it doesn't need to be in the resource slice status. It could also be a separate object.
Mm-hmm.
Uh,
Okay.
my thinking was with resource slice status. If it's one well-defined place, then you can have two schedulers and you don't, and they both can coordinate through that well-known
That
place
object.
with
Okay.
atomic updates of a status. So they record their reservation. If their status update succeeds, they know that they basically own that resource, that device, or that they hold the reservation. It's a bit
I
like
see.
leader election. And the other scheduler trying to do the same sees a conflicting status, sees a conflict during the status update. He knows that it didn't succeed with taking that reservation. It allows coordination without a third entity
Mm-hmm.
because
Okay.
both schedulers make the status update in the same place. If they both create a reservation object, they both manage to create those reservation object because it's basically an arbitrary name, there's no conflict. And then you have to have a third component that watches all reservations and approves them. So it's a different design where it's either my proposal with resource slice status was cooperative between two competing entities without some arbiter. And
Yeah.
the one with a separate object is basically depending on someone else making a decision. Both is
Okay.
viable, I think.
Okay. I see. I see your point.
Yeah. The problem in either way will be that the scheduling becomes slower. So we have to be aware of that because it's no longer the rapid one port after the other scheduling that we have had traditionally.
Sure. Like we could have, besides of allocation, we could also have a reservation step. So
Yeah, but
so
that means each pod scheduling needs to wait for an acknowledgement by someone else.
of the reservation,
Yes.
well, so one approach is to have arbiter for reservations. Another one is to have clear rules for who
Yeah.
has precedence over
Yeah.
who. So you may have like more important scheduler and less important scheduler,
Yeah.
or some other rules on the level of workload.
Yeah. I think it all works, but it does add overhead. So we have, I think that's my point.
Okay.
And that it may be perfectly fine because you want this feature and it's more important to have that capability in your cluster than it is to have rapid scheduling. But you can't have both, I think.
Mm-hmm.
And the thing is, you also can't say, I do rapid scheduling for some workloads and I do slow scheduling for others, because if something in the cluster schedules pods without honoring that reservation system, whatever it is, whichever approach we take, then it breaks for ones that do want to use it. So it's almost an entire a decision for the entire cluster whether resources are managed with or without reservation.
Okay, I have one more question because it was always confusing to me. We also have the reserve for, and the reserve for is for the whole resource claim. It's not for device
Yes.
that is assigned. So if we have few devices and we have few pods that can use this resource claim, they can share those resources. So is there an assignment? How pods know which device they should be or will be bound to? Is it just a node boundary that defines which devices are physically?
The pods get the devices allocated in the claim. And inside the pod owner defines which containers get which devices through the request mapping. So
Okay,
I'm not sure whether that answers the question, but basically the workload owner defines the resource claims, defines requests inside the work claim, inside the resource claim, and in the pod maps the requested devices to containers. So it's all under control of the workload author. And which devices those are, that's the resource claim allocation step. And it looks at the requirements, at the request selectors, device class selectors, the match attributes, all of that makes sure that the workload gets what it was asking for.
so if there are more pods using the same resource claim,
They get the same devices. So allocation only happens once.
allocation of the devices to resource claims happens only once, right?
Yes, yes.
Okay, so the new pods that join the resource claim, so you are saying they have assignment to specific devices?
They share the devices with the
They
other
share,
pods.
but how is there any additional annotation in a pod which exactly device which pod share, or it shares all the devices?
Well, it can pick requests within the resource claim for its containers. So if you have a resource claim that has 5 requests, and each request is for one device, then you can have, say, one possible scenario is 5 pods sharing that resource claim, and each pod using one device, one different request.
Okay.
In that case, each pod gets one device exclusively, but that's a question of how the workload is set up. It doesn't have to be that way.
Okay,
The
but
same,
if it is this way, then who decides which device, which pod is
the
used?
workload author. In the pod spec, you reference the resource claim, and in the container in the pod, you reference requests by name. So
But you reference request or device that is allocated?
a request, and you don't
Request.
care what was allocated. You just say, I know my resource claim has request 1, 2, 3, 4, 5, and in pod 1, my one container uses request 1, and whatever was allocated for request 1.
Okay, so we could say that all pods basically share all devices that got assigned.
Yes, and it's up to them how they use them.
Okay. Okay, so I'm asking in the context of, because we had an idea or actually implementation that we could use resource claim as a region or a topologic constraint that can restrict like picking only one rack for a like group of pods.
Yeah.
So it works well, but I'm thinking, what if we want to have topology spread instead? So
Yeah.
we want that each pod receives a different device, and device would be a topology domain in the topology constraint. So is there a way then to do that, or
We can't, I don't know exactly what the constraint is and where to put it. But perhaps one thing is relevant in that context, and that is the coordination of which devices get allocated together. So if you have multiple requests in a single resource claim, you can have constraints that limit which devices go together. That's the match expressions. I think it's the only constraint that we have right now. The match attributes must match, but conceptually, the only API that we have to set such constraints is in the resource claim. So if you have one resource claim with multiple requests, you can set constraints for those devices. If you have two claims, you can't. So two claims, one device each, can't have constraints because we don't have an API to define constraints across claims. It's all in the resource claim API. And that is a gap in some sense, because logically the allocation happens for the first consumer. So if you have one pod referencing two claims, it would be kind of natural to also allow specifying a constraint for that pod allocation. And that constraint then needs to apply to all devices across all resource claims. The only reasons why we don't have that is that it would need to be in the pod spec, it would need to be in whatever is triggering the allocation. It could be this higher level workload API that we discussed.
Or pod group, because this is
pod group. Pod group. That could have a constraint saying, for all devices that get allocated through DRA, the following constraints must apply. But that is something that needs to be in that object. For the pod, we didn't do that initially because it was V1 when DRA was alpha.
Okay.
Putting something like match expression at a time when that concept was still experimental right into the V1 pod spec seemed a bit premature.
Sure.
We weren't sure whether the API is right, and changing the pod spec is always something that you should be very sure about. Now that it's GA, we could definitely revisit that topic and say, okay, match expression is a V1 API in the DRA resource API. Let's take that same concept and put it into the pod spec because it's mature. We know that it works. We know that it satisfies use cases, and basically lift that constraint up one level so that it applies to multiple resource claims. That would be entirely feasible. We just need to know whether that is something that people want.
Okay. So if we have one resource claim then, and we can have a spread requirement so that devices are different at some attribute. I'm not sure what's the name of it.
I think I called it anti-match attribute at some point. I don't think it was, where was it? There was a cap where this came up.
Okay.
Yeah, but it's not implemented right now.
Oh, it's not implemented?
No, I don't think it is. It might have been the, wait a second. Which cap was that? I'm looking at the list. Was it consumable? No, it was not consumable capacity. I forgot. It doesn't even appear in our list, the one that I'm thinking of, and I don't see it.
Okay, but anyway,
yeah.
So it should be possible to allocate devices that are different at some attribute.
That's where I'm getting it was proposed. So basically, the requirement would be it's a new constraint that says some attribute must be different.
Okay.
Whereas right now it says it must be the same.
Okay.
I remember the discussion. I
Sure.
don't see the cap being listed here.
Sure. It's even not that important whether it is implemented or not, but if we have those devices different in some way, then if we have also 5 different devices and 5 different pods, then they also don't have this assignment between each other. There is no concept device assigned for this particular pod.
Not within a resource claim, no.
Okay. Okay, that's what I wanted to make sure
Okay,
that
yeah.
my understanding is correct.
Yeah. The scheduler is not aware how the devices are going to be used in the pod or in future pods, because it does the allocation once it sees the first pod. So it might see a resource claim with 5 devices and it sees one pod using one device, but that doesn't mean it knows anything about the future pods. Not the way how it's currently done.
Yes, and the only mechanism that we have is that resource claim has a loop back, can restrict the nodes that can be allocated by new pods, node selector or node constraints.
Yeah, once you have a resource claim allocated, we compute a node selector that basically says,
node selector.
if you want to use this resource claim, it has to match this node selector, and that's determined based on which devices were allocated.
And this is how we restrict the scheduling of the.
And then the next pod that uses that resource claim is limited by the choice made for the first pod.
Yes. Okay. Yeah, great. That's all interesting in the context of this gang scheduling, because that's that is the core of. Okay, so thanks for the discussion.
Yeah, that's what we have this meeting for. Thanks for asking. Otherwise, it would be a boring meeting. Okay, I see another raised hand. Masahura, did I pronounce that right? I don't know.
Thank you.
Yeah.
I'm Masaharu Kanda. Yeah, I'm Japanese, so the pronunciation is a little difficult for you. So, sorry for back to 134 status. So I'm interested in gRPC idle timeout issue. So please give me a link of that issue.
Yep, just a second. I'll get it for you. I need to go to our board. So let me also put it into the notes.
I think I pasted in the chat. Is that the one?
Let me check the chat. So it's
Yes.
Yeah. And that's the gRPC idle timeout.
Yes, thank you. Yeah, in the chat, yeah, side.
It's the same.
Yeah. Thank you. Yeah, I got it.
Yeah. In general, if you want to look at what's going on with DRA, let me also just open our dashboard again, in case you're not aware. So this is the high level view of what's going on. I'm trying to keep it updated, and if you are trying to participate, you can find work to do by looking at the in review column. That's what people are submitting for reviews. So if you're interested in figuring out what's being actively worked on, the in progress and in review. In progress typically has the issues. In review are the PRs that literally need a reviewer right now. And then the done column, I'm a bit unhappy with GitHub here. If I click on a link and move it to a column, I could do that. I could move it to done. When it ends at the bottom of that done column, what I tend to do is I manually drag and drop. So if I see something like this one here, it got resolved. Moving it to done is still a manual thing that I do from time to time, and I move it to the top. So at least if that's done consistently, you can look at the done column and see the things that were recently completed, and that includes the regression that I just mentioned.
Yeah, Patrick, could you share the link of the dashboard?
I'll put it into the notes.
Thanks.
I think we also have it in our chat, in our Slack chat, as a link for the channel. But it's worth calling out a few times from time to time, because people tend to forget that we do have this. Yeah. And it's not consistently maintained. I think I'm the only one updating it, which perhaps we should change. So the new column, for example, if you are consistent with applying the working group device management label to new things, new issues, then it shows up under new. That's an issue for issues because they don't get that label automatically. But if you put it in if you do it manually, then it shows up here. PRs are a bit better. We have owners files so that a bot detects which files get modified. So PRs typically tend to show up automatically or get the label automatically. We also have some false positives. So global changes like this one here with Fix a Panic for CRD, that is something that touches lots of files and it just shows up. What I tend to do is I briefly look at it, determine that we don't need to track it as the working group, and then I archive it. That makes it disappear. Yeah. But in general, working group device management meeting, that would be a good time to go through this. And we probably need to do that because here are some of the new things. Some of them are fairly old. I'm not even sure whether they are relevant, but we need to triage basically and need to determine whether that is something that needs to be worked on. And for some of these, I don't know what to do. That's why they are still left in new. It needs just the first step would be to discuss what to do about them. Whether it goes into our backlog or is ready to be worked on for the upcoming release. That would be the first step to get it out of new. For some of them, I know what it is, and I just make that decision myself, but sometimes more discussion is needed.
I have a question, Patrick. So with this, I think this is related to the external resources kept. So with the issues created, how do we start the process? Like when do we start developing on it? Like these issues tend to appear in the new column. So when do we actually move them to backlog and then ready state?
You can basically move them yourself. Any contributor can move these issues, which kind of makes it an honor-based system because there's no control that it doesn't get moved when it shouldn't be moved. But for things where the people responsible for the issue or the PR know that it shows up in the new column and they know that it should be under review, just move it.
Okay,
Or that
thanks.
it's in progress. As long as we all follow more or less the same rules, it's okay.
Okay.
Yeah. And you are doing your own triaging here. So basically anything that is related to this issue here, promotion to beta, do we have it? We must have it in the board somewhere. So we might as well triage that now. So
Yeah, the first one that
yeah,
I
so
was
that
assigned to
would be the
myself.
most obvious. That promotion to beta, it is something that we are planning to do. It's an issue that
Okay.
is in progress.
The very first one that
That also you already decided that this is worthwhile. I've seen the comments. Basically, if you all have decided that this is something that needs to be worked on in this cycle, we can just move it, and that's it. And I can, as we are now looking at it, I can also move a few more things. So some other thing that I've been doing is looking at our scheduler perf testing. I found issues with it, notified people. Some of these PRs are fixing that. So that's also in review. Okay. That was a good reminder. Perhaps I should make it a standing topic also for this meeting here to look at the board and see whether anything is on that board that we can resolve and triage. I should definitely also do that for the Tuesday meeting because that has a different audience. Other people might know about some of these pending new things. Okay. Anything else? Let me just capture some of our topics, perhaps. Now I need to be sure. Do you have a what's your GitHub handle, Dominique?
DOM for
No.
HA.
So that was right. Okay, yeah. There's too many names for different people. GitHub handle, Slack handle, real world handle, nickname. It's too much for my poor brain. I did remember this case.
And there is no way to match, between the systems.
Yeah. I'm just saying discussion around resource reservation, constraints, etc. We'll have a recording for anyone who's interested.
Yeah. Okay.
Yeah. We're at the end of the hour. Thanks for the participation. It's good to have people come with questions. See you next time.
Thank you.
Thanks all.
Bye.